Hi, this is Rob. I'm on my way to work. Traffic's been a bit of a problem up till this point, but might be a couple of minutes late. But I've got quite an interesting project I'm working on today. So the company I work with at the moment, they make professional and commercial sort of bespoke induction hobs for the restaurant, hotel, catering industry. You know, they're UK made, and they are like the Rolls Royce of hobs. They're sold worldwide, and obviously worldwide people have different sort of power, different voltages, different frequencies. Typically ours are sort of made for the UK domestic market, but they do go all around the world. We are sort of 230 volts, 50 hertz in the UK. A lot of other countries are actually the same. They might have different sort of plug types, but you know, the voltages do vary, but there are a lot who are on sort of 230 or thereabouts. So yeah, what's happened is we've got quite a lot of our hobs are on sort of cruise ships and things like that. Now, cruise ships are a bit different. They generate their own sort of power. They sit in the middle of the sea, so there's no sort of physical earth connection. So they're a bit different. Maritime sort of electrics are probably, or marine electrics, whatever you want to call it, are, you know, it's not something I know a lot about, but obviously I know what the basic requirements of our products are. Now, seem to be having a few sort of problems, not massive problems, but problems where they say that the hobs aren't working, or they're working at lower power but not at higher power, and they're coming down with sort of shutdown 1 codes, which generally sort of indicates under voltage or over voltage, or it can mean other things as well. So, you know, we did send replacement parts out. Obviously on a cruise ship you're a bit limited, you can't do a site visit easily, although we have done that and gone to New Orleans before, to a cruise ship who are having some problems. So yeah, we've sent replacement parts out, which they're sort of engineers on the ship have either fitted, or they've sort of mocked up to sort of see what the sort of result is and whether they still get the shutdown 1 faults. I should clarify this actually. So some of these hobs are sort of 6-7 years old at this point. The original faults weren't shutdown 1, it was just the hob is low powered compared to its next door neighbour hob. For example, say they've got two hobs or 3 hobs in a row, or whatever it is. One's the odd one out and it's sort of underperforming compared to the other 2. So that was the original fault, which, you know, electronic components do sort of degrade over time, and heat and other things. So, you know, that's expected if they get a lot of use. Obviously on a cruise ship they're going to be sort of used a lot, different sort of meal times. People want food, they're going to be hammered, these things. So it's what they're there for, but you know, nothing lasts forever. Things do need sort of service from time to time. So that was the original fault, was low power. Now, the replacement parts we sent out, they're slightly different, whereas they're sort of designed to work on 50 and 60 hertz. That's what we call sort of the universal, because that will work all around the world basically. You know, people are on 50 hertz or 60 hertz. Voltages obviously do vary. I'm not an expert on that, but I think our stuff is really 230, but it can be 50 or 60 hertz. Okay, so when we sent the replacement parts out, they would sometimes work on lower power but not higher power. They come down with these shutdown 1 messages, which are sort of lower, you know, under voltage, over voltage, or, you know, can be other things as well, or combinations of those things. So, you know, all these things are thoroughly tested in our sort of workshops before they get sent out. So we're pretty confident that actually there's nothing wrong at our end. But you can't ever rule it out. I don't know where these ended up getting sent to. It was air freight, you know, and somehow had to make it onto a cruise ship somewhere. So things can happen in transit. So we said, look, we're going to need those back. but we will send you sort of replacements out. And again, we made sure they were thoroughly sort of tested. Everything was good at our end. Gets to the other end, same fault. I think, right, okay, it's definitely not our stuff. It's a voltage stuff. It's a voltage thing. So we asked the engineers, technicians on the ship to check the power at the sort of supply sockets, you know, to see what they're at. Now, there is in the UK, so it's 230 volts AC at 50 hertz. It can be plus or more, I think it might be minus 10% or plus 6%. So I'm not entirely certain on which way round that is, but basically you got on the lower end that our sort of national grid have to supply to your sort of your electricity meters, minimum of 216.2 volts. That's the minimum. The maximum is 253 volts. Now, obviously, there's a big difference there, and the products have to work within that range. Not everyone's going to have high, medium power. Some people, especially on overhead lines, if you're on the end of the line somewhere, you know, you might have a bit lower voltage, or there might be a dicky transformer on a pole somewhere, or I don't know. So yeah, we think the problem is potentially sort of low power. There's lots of things all needing electricity on a ship. The only way to tell is to make a device where you can sort of vary your supply voltage. Now, that's called a Variac. We did have a Variac at this company before, but it got, I think, loaned out to somebody, or something happened to it. It's not a piece of equipment that is used all the time. Now, unfortunately, the person who sort of loaned it out or did something with it, they don't work here anymore, so we don't know what happened to it. Now, although these things are a bit sort of antique looking, you have the ability to vary your sort of you know, say you get 243, you know, your line voltage is 243, okay. With a Variac, you're able to go below 243, you're able to go all the way from sort of almost no volts at all up to your 243, so you can check for sort of lower power sort of situations. But if wired in a certain sort of configuration, you're also able to go over your 243. So say your incoming voltage is 243 volts, and you suspect that a particular sort of customer is having high voltage, which is causing problems, you know, this Variac will take that all the way up, I think, to about 274. So it will go, you know, from nothing to 274. So it's very easy to sort of dial in what your customer's power is or thereabouts, and sort of test that, what they think is faulty engine, to see actually is it a faulty sort of engine. Engine is what we call the sort of induction panel, basically, all the gubbins underneath the glass. So we don't think there's anything wrong with these. The only way to find out is to have a Variac. And my little project is, we've sourced a Variac. They are very expensive, brand new. In the UK, the one we need, which is sort of 15 amps, you can handle sort of 15 amps. All our things are sort of 13 amps when tested individually. You know, if you got a 4-zone hob, it'll be like 12 kilowatts, I think. If I'm wrong, I'll put a little note somewhere about that. But yeah, obviously you check these things singly, because, you know, it's the best way. If a zone is faulty, you test that zone. You test everything else as well, but, you know, you concentrate on that one thing first. So yeah, a little project today is to make this Variac. They're very expensive in the UK. The one we need is about £840 odd. That's a lot of money for something you don't use very often. So I did a bit of sleuthing and found one on eBay, basically. It was brand new. I think somehow it had come via an auction, and it ended up on an auction site as well. So, you know, they showed pictures, it looked completely fine. It was an RS Pro branded one. RS are very well known in the UK. I don't know if it's got anything to do with Radio Shack. That's sort of RS as well. Obviously, I don't think it is. But it used to be RS Components. They do lots and lots of things. So yeah, I saw one on a very popular internet auction site, eBay, I'm going to say it. And basically they were sort of advertising it for sort of £300, and it was on there for a long time, and it went from £300 and £200, and eventually it was £200 all made me an offer. So I made them what I thought was a very cheeky offer. I felt a little bit bad about it because it's I don't want to insult anybody, but I offered them £100. You know, these things you could probably scrap it for £100. You know, it's very, very heavy, got lots of copper, made of solid metal. Obviously shipping the thing's not going to be cheap either because of the weight of it. And they said yes, so bought this sort of Variac. It's arrived, it looks fine. You know, I think the sort of dial ended up being a little bit sort of bent, but not massively bent. It could easily be sort of straightened with a few taps of a hammer in the right places. But yeah, my project today is to, and I've just realised I was going to bring a ratchet spanner with me and I forgot. Never mind. So my project today is basically to get this Variac wired up, figure out how it's wired up. There's 5 terminals on it. There are different ways to configure it dependent on how you want to use it. So I'm going to sort of, it's going to need obviously I think a Type G socket for our UK plugs. It's also going to need a sort of a fly lead with spade terminals, 6.3 female spade terminals on it, insulated of course. I don't want anything shorting out, so we can plug them into, you know, our induction engines. So it's going to need both of those things. Also, the Variac doesn't come in a housing. It's just a bare thing. It's meant to sort of fit into something. Now we haven't got a something. We're going to have to make a something, or find a something, or whatever. But yeah, we're going to have to make a something. So yeah, that's my little project for today. I'm going to sort of get to work. Well, I'm going to stop waffling, get to work, show you this, what we've bought, and go through the process of trying to get it all wired up, get it all sorted. You know, find a housing, make a housing, you know, I don't know. It's probably going to be made out of wood, which is not ideal. Saying that, wood is not conductive, so, you know, you'd still need to earth the Variac, ground the Variac, but you wouldn't, you know, I suppose that the danger from getting electric shock off the metal case or whatever is not there, because it's probably going to be made of wood. So yeah, that's it. I'm going to stop waffling, get to work, and figure out what we're going to do, how we're going to do it, plan a bit of a, you know, sort of plan at least in my head what we, you know, how it's going to work. Might not be able to do too much recording at work. I don't know how work would be with me doing that. If we do some recording at work, you might hear some sort of background people chatting, or even our workshop cat Laszlo will probably come and try to help. He's a delight, but that's a totally different story. So yeah, that's it. Waffle over. I'm going to go to work, have a cup of tea, and figure out, you know, a bit of planning basically. Also, I think try and sort of put some paint on it. It's almost certainly going to be made of wood. It's going to look very, very homemade from the outside. On the inside, it's going to be totally done correctly. Obviously, beauty is in the eye of the beholder and all that. So, yeah, give it a coat of paint as well. Final assembly won't be till the paint dries, obviously. And yeah, I'm quite clever in the head. Got a certain way of doing things, and I want things done right. I want things done safely. You know, going to put nice sort of connections on all of these things. Don't like these pre-insulated things. I just don't like them. You can't see how your crimper's gone, sort of thing. So I'll try and avoid those at all costs, because I just don't trust them. Plus they look they just look naff, you know. They look very, it looks like you've made it, well, it looks like you've made it in your garage at home, sort of thing. And I make a lot of things in my garages at home, but I try to make them look nice, and I really don't like those things. So try and avoid those. Coat of paint maybe, final assembly after the paint's dry, and then we'll try and do a video of you know, actually it working and what it does. Yeah, so that's it. Waffle over. I'm quite clever in my head. I know what I want to do. I know how I want to do it. I know it needs to be done well. It's going to be cable ties used, which is, you know, brilliant. Cable ties are like the second best thing I think we have. The first best thing is, you know, a God who loves and cares for us. There's nothing we can't do with God's help, whether you believe or not. That's my opinion. So yeah, we've got on cable ties. This is going to be a walk in the park. So waffle over, drive continues, and catch you when I'm at work.